Okay, Assalamualaikum and very good morning to all my dear students. So, how are you today? Madam hope that all of you are doing fine during this week. Okay, today we are going to continue our lecture on 2.4, which is integrated sampling device, the principle and assembly train. Okay, we recap what we learned on the last week. Basically, we learned that we have two types of instrumentation or technique, which is direct sampling or integrated sampling. For direct sampling, we put the device and we can get the reading at the moment. Okay, for the integrated sampling device, we need to send our media filter or solvent tube or impinge bottle to the laboratory for analysis. Okay. Okay, the principle, okay, the most important principle of integrated sampling is the calibration of the sampling pump flow rate according to the chosen method. For example, NMAM 1505. NMAM is stand for NIOSH Manual Analytical Method. And the commonly used calibrator is a digital type calibrator and bubble type calibrator. Okay, this is the example of NMAM 7400 for asbestos and other fibers. Okay, from this we can know the flow rate. For example, from 0.5 to 16 liter per minute, and the volume minimum and maximum. Okay, so how to calculate this flow rate and volume, we will learn on the next chapter, on chapter 4, I guess. Okay, so how to find the NMAM? Okay, you just Google it. For example, you type NMAM 7400 and it will appear in your screen. Okay, this is the bubble type calibrator and this is the digital type calibrator. Okay, most of the industry use the digital type calibrator. However, the bubble type calibrator is more precise. Okay, it depends on your company later on when you enter into the working area, which type do they prefer. Okay, this is the approaches of integrated sampling. Okay, basically we have this sampling medium inside this container. We have the flexible tubing and we have pump here, and this is the workers that we want to sample. Okay, first of all, put the media filter, which is filter paper or solvent tube, into the holder or container. Okay, basically there are a lot of the commonly holder that we use is cassette. And then we connect the container that contain media filter with sampling pump using the flexible tubing. And the air enter the inlet and passes through the sampling medium where the contaminant is absorbed or otherwise captured, and then the air will move on through the pump and exit. So here we capture our contaminant in this container or holder. Inside this one we have the media filter. Okay, the assembly train, basically we have three components that we are widely used, which is sampling pump, sampling tube and media filter. Okay, for sampling pump, we have standard flow and low flow. Standard flow have a capacity to draw air from 1 until 5 liter per minute. And for low flow, it have capacity to draw air less than 1 liter per minute. Okay, so this is the velocity of the pump. And then we need second component is sampling tube. It have Tygon type, Teflon type or silicone type. Okay, for media filter, we have a filter. For example, PVC type, PTFE type, MEC type and glass type. Okay, for tube, basically we have charcoal, we have silica, we have hypocalypse, and usually used for vapor and gas. Okay, this one is the impinger. Okay, as I mentioned earlier, the impinger is a passive. It does not need any sampling tube or sampling pump. It just need the media. Okay, this is the general. Okay, we have pump, we have tube, and we have media. Okay, this is the sampling technique for airborne contaminant for particulate. Okay, this one is the sampling head for inhalable dust. Okay, for the inhalable dust is a dust larger than 10 micrometer but smaller than 10 micrometer. So we will use the cassette as a holder. Inside the cassette we have PVC filter with a size of, for example, 37 millimeter, and the air will going through this cassette and filter and moving through this tube and going out through the sampling pump. Okay, this is the sampling head for respirable dust. Okay, what is respirable dust? Respirable dust is a dust with the size of less than 10 micrometers. So it is very small dust. Okay, so for respirable dust we need to use cyclone. Okay, why we need to use cyclone? Because respirable dust is dust that has a very small size. So when we have cyclone, we can capture the larger particle here. Okay, first the air will flow, and then the larger particle, which is larger than 10 micrometer, will going downward and accumulate in the bottom of the cyclone, and the smaller one, which is less than 10 micrometer, will going upward through the cassette and PVC filter and going upward through the tubing and going flow out to the sampling pump. Okay, this is the example for sampling head for fibers. Okay, fibers, for example, asbestos. Okay, so we do not use cassette as holder. We use cowl as holder with the MEC filter size 25 millimeter. MEC filter have a grid. Okay. Okay, so let's recap on the asbestos. What is asbestos? Asbestos is a contaminant with the characteristic of thin. Okay, have a length larger than 5 micrometer and width less than 3 micrometer. So when we take the example of the asbestos, we can count how many asbestos in the MEC filter, which is this filter is come with the grid. Okay, so it is easier for us to count how many asbestos. That's why we need to know the characteristic of the asbestos so that we count the right contaminant, not other contaminant. Okay, this is the sampling head for film. Similar, we have a cassette as holder and we have MEC inside this holder, and the air will flow through the tubing and going out through the sampling pump. Okay, that's it, and I will continue on the next slide.